Hey guys, this is Josh Myers from Academia on Demand, and today we are going to be doing our first theory video on the evolution of the atomic structure. So, this video is super important to the validity of this channel because we can't have a real chemistry channel with real stuff, with atoms, with electrons, with protons, without knowing exactly how it all came to be. So let's start out 400 BC. Let's go back an entire more than 2,000 years, all the way to a man we have a picture of today called Democritus. Democritus was a philosopher, a Greek philosopher, and he favored the idea of reason over hard proven data and science. And so he was the first recorded person to talk about the idea of atoms, the idea that matter was made up of smaller subunits called atoms. And so he is therefore the founder of the theory of atomism. And he called these smaller subunits atomos. Writing sideways is difficult, children. Okay, so another thing that Democritus also founded was the idea that matter cannot be created. Matter is not created or destroyed. This is essentially what later Lavoisier will prove to be the law of conservation of mass. Matter cannot be created or destroyed. Matter cannot be created or destroyed. And so what is really interesting with Democritus is that he, as I said before, favored reason over science. And he was a philosopher. He was not someone who sat in a laboratory, or even if they had laboratories back then, to do experiments, to have data. He made all of his statements based on observation, based off of everyday observations through the senses. And this is significant because though a lot of his ideas were right, though he's one of the first people to see matter as smaller subunits, as atoms, he was opposed by very many people, such as Aristotle and other philosophers, who, just as him, they were just thinkers. He did not have the experimental evidence. He did not have the experimental evidence to back up his claims. And so therefore, though later on, the next philosopher, next real scientist we're going to talk about proves many of the things that he said, just shows how important experimental evidence is, how important being able to prove your claims with rationale is. So now let's go on to the next flip forward 2,000 years later, and what we have is someone who is able to prove Democritus' theories through the research of others. Erase. Almost there. Give me a couple more seconds. Alright, so the scientist we're going to talk about, his name, John Dalton. John Dalton, 1803, published his big theories. That pen is very squeaky. John Dalton. And he was a very interesting guy because he was an extraordinary study. He went back and examined many of the people before him, many of the scientists who published studies, who published results on different observations they had made in the chemical laboratory. And what he found, he gathered all of the data. And what he found was confirming of Democritus' initial theories more than 2,000 years earlier, that confirming the idea of atomism, that there are smaller subunits to matter, that are subunits subunits to matter, called atoms. Very nice. Atoms right there. And another thing that he proved of Democritus was the idea that matter cannot be created or destroyed. And though this is not technically true today, Chadwick proves this later, and we will talk a lot about Chadwick as well. For now, matter cannot be created or destroyed. And this is extremely important because later on in later videos, Lavoisier was technically the one to prove this through his own experimental work. Lavoisier was an absolute genius at the ability to manipulate experiments and be able to get these pinpoint results according to the theory that Dalton created. And that's why in later videos we will talk about in chemical reactions how mass is not lost from start to finish. And finally, Dalton, the last thing Dalton came up with was that all atoms of a substance, all atoms of a single substance, have the same chemical and physical properties. Properties. And so this is where this becomes really interesting because John Dalton, he takes what Democritus did and he makes it a science. He makes it a theory, though at this point they still don't understand exactly what an atom is underneath it. They don't understand the concepts of electrons, of protons, of what Chadwick would discover to be neutrons. But they understand, at least it's accepted by the time of John Dalton when he writes his theory, that matter is made up of smaller subunits called atoms. Okay, so now let's go on to the next philosopher. Next scientist. I keep saying they're all philosophers. They are scientists. Major difference we've already talked about. And I'm going to introduce 3 scientists right on the spot who single-handedly came up with the structure, working together, came up with the structure of the basic structure of the atom. And so I'm going to pull out 3 men, very, very important, whose discoveries were published within 15 years of each other. We have Ernest Rutherford, Niels Bohr, and the James Chadwick that I've been talking about. So, Ernest Rutherford. And what he did is that he took the first look at trying to establish the idea of the nucleus. He came up with his gold foil experiment, and he did not know exactly what he was to find, but through performing this experiment, what he did is he was shooting, let's write gold foil experiment, gold foil. And what he did is he took a beam of alpha particles, and these particles are basically what we know today to be a helium nucleus, which is consisted of the proton that Rutherford is just about to discover, and the neutrons that Chadwick later discovers in 1932. This is 1917. And he shoots a beam of these alpha particles. At the time, they did not truly understand what an alpha particle was, but they were able to use them in experimental laboratories. And they shot it through a slit into a chamber containing containing an atom. And what Ernest Rutherford thought would happen, his hypothesis was that the alpha particles would shoot right through, that they would literally go right through this atom, and this would prove that there's no significant solid substance, in the middle of the atom. But what really happened is that when they made contact with this atom, they scattered. Many of the alpha particle beams scattered. And what this came to prove, what Rutherford soon figured out, was the idea that the atom is made up of negative particles that they called electrons. They'd already discovered that, but it also had a nucleus, a solid nucleus of significant mass relative to the electron, right in the middle that reflected these alpha particles. And he came to know that they had a positive charge, and that they were significant in keeping the atom together. So now we will erase. And then now we're going to talk about Niels Bohr, a Danish genius. Who solved a major piece of the puzzle when he came up with his theory of energy levels. Niels Bohr. And what he said, because at the time scientists were extremely puzzled with the idea that electrons did not fly into the nucleus, that even though there was attraction between the positive proton and the negative electron, that the atom did not collapse within itself. And what he said, the reason for this is because of energy levels. And these he defined them as the paths that an electron must take when orbiting the nucleus, and that they cannot deviate from this path when they are traveling around the nucleus. When this came to be known strongly, once examined by later scientists, as completely true. And finally, we talking about Chadwick. As I've stated before, he discovered the neutron, the neutral particle in the nucleus. Because based on the work that Ashton did, there are isotopes, which meant that there were atoms that were the same substance. They had the same number of protons, same number of valence electrons, and we will talk a lot about valence electrons later when we do our orbitals video. But they discovered that these seemingly same atoms had completely different masses, and this what inspired the idea that Chadwick later discovered the neutral particle that did not have charge, and it had significant mass, and it was called the neutron, and it exists inside the nucleus with the proton, with the positively charged proton. And so if you put these men's discoveries together, not only did we go from understanding that matter was made up of atoms from the time of Dalton in 1803, in less than 130 years, humanity came to know exactly what this thing we call the atom looked like. And so let's draw our atom. The nucleus, let's draw hydrogen. Hydrogen, as we'll learn in a very, very soon-to-be video, that it has one proton, one neutron. Neutron, proton. Proton has a positive charge, so you'll get used to seeing this. And the neutron, being a zero, has not charge. It does not have a charge. And then the first energy level that Bohr talked about. First energy level, and the electron, the dot right here, the electron. And this electron is orbiting the nucleus in this energy level. As I said before, it cannot leave that energy level. There's a lot of physics behind this, but in the grand scheme of things, it cannot leave this energy level and come closer to the nucleus. But as well, one of the things that Bohr discovered is that there are other energy levels. Even if there are no electrons in this other energy level, the energy level still exists. It still exists. And what happens is that, and we talk about in a later video about the emission spectra, this electron can be excited. It can be excited up to the next energy level, and this has some serious implications, again, that we will call the release of light. It will release light or some other wavelength of what comes to be known as the electromagnetic spectrum. And so this model of the atom, let me draw one more energy level just to really give us a good idea of what this looks like, so that later on when we're talking about these atoms, we're all talking about the exact same thing. So this structure of the atom that Bohr, Rutherford, Chadwick all came up with together, not physically together, but their ideas are combined to create this thing we call the atomic structure. And so for the purposes of this channel, this is the atomic structure that I'd like you to accept right now. Later we will talk about orbitals, we will talk about exactly what these energy level things are, what's underneath them, just the way that they described what's underneath the atom that Dalton described in 1803. Alright, so thank you very much for listening to this first theory video, and I hope that you continue watching. In the next video, we will talk about the periodic table. Alright, see you guys.